Bismillah ar-Rahman ar-Rahim. Continue. That was the last one. Now let me continue. I have first three non-zero terms of this Taylor series. Okay. So my f of x is sine x. F prime is cosine. F double prime is minus sine. This is what I need. So f at pi over 4. Because at pi over 4 always it's non-zero. So it will be square root 2 over 2. F prime at pi over 4. That will be square root 2 over 2. F double prime at pi over, this will be minus. Okay, now the function will be written as well. F pi over 4 plus f prime pi over 4 x minus pi over 4 plus f double prime pi over 4, don't forget, over 2 factorial x minus pi over 4 square plus the rest. What is f of pi over 4? Square root 2 over 2. Prime, same. That will be minus square root of 2 over 2 over 2. That will be over 4. Plus the rest. I need the first three non-zero. Actually, I need P3 only. Huh? So P3 of x or P2 of x. P2. I need up to P2 of x. It will be this, which is this one. The Maclaurin series of this function. Okay. What I have x plus 1 all square in the denominator. So I need to think about this. This is 1 over x plus 1 all square. It's what? It's the derivative of 1 over 1 plus x. Now this is make it minus sign. So it's minus 1 over x plus 1 all square. This is the derivative of 1 over 1 plus x. Yeah, I need the minus sign. No problem. I will deal with the minus sign later. So I will start with 1. We'll start with this one. So this is, I know, it's this one. Minus 1 to the power n, x to the power n. Now I need to differentiate this. So minus 1 over 1 over x plus 1 over 1 plus x, who cares? X plus 1 all square. That will be the derivative of this one. This is a number. What's the derivative of x to the power n? N, x to the power n minus 1. Now to get this, I need to multiply by minus x square. So let me write x square. This is my target. For x plus 1 all square, it's minus x square times this, which I just did. And that will be, I need to multiply minus x square by this expression. So that will be summation n equals 0 to infinity, minus 1 n plus 1, n x to the power n plus 1 plus 2, n plus 1. And that will be the answer. The Taylor series of this, he expanded only. Expand 3 terms. Okay, so let me do it. E to the power 2x. So I need e to the power x. So it will be x. Instead of x, I will write 2x. That will be 2 to the power n, x to the power n over n factorial. Okay, sin x, sin x. Sin x is this. No change. The argument is x. This is factorial. Okay. Now I have e to x times sin x. Let me list it. I need up to x cubed. Okay. So I have this at n equals 0. I have 2 to the power 0, x to the power 0. That will be 1. At n equal 1, that will be plus 2x. Okay. At n equal 2, I have what? N equal 2, I have 4 x squared over 2 factorial. plus n equals 3. I don't need it, but it's okay. 8x cubed over what? Over 6. Okay, plus the rest. Now, for sine at n equals 0, I have what? X. At n equal 1, I have what? Minus x cubed over what? At n equal 1, that will be 3 factorial, which is 6, plus the rest. Okay, now what will bring me coefficient constant? Nothing. Coefficient of x, this times this, that will be x. Coefficient of x squared, this times this. That's the only thing will bring x squared. So that will be plus 2x squared. Now what will have a coefficient of x cubed? This cube, I have 1 times this, which is minus 1 over 6. X will not give me x cubed. 4x squared multiplied by this, 4x squared over 2. That will be 2. That will give me plus 2. That will be x cubed. So this one will be x plus 2x squared. 2, which is 12 over 6 minus 1 over 6. That will be plus 11 over 6 x cubed. Plus the rest. So that will be my answer. Evaluate this. Okay. I have 2n plus 1 factorial. So what comes to my mind? Sine. Put sine in front of me. Okay. Now this one I can rewrite it. Minus 1 to the power n. I can combine this with this. But I have 3 to the power 2n here. And I have pi to the power 2n plus 1. Okay. So I have 3 to the power 2n. Multiplied by 3 here and here 3. To make it 3 to the power 2n plus 1. Times 2n plus 1 factorial. So that will be 3. Take the 3 out. This 3, take it out. What is the remaining? Minus 1 to the power n. I have, this is 3 to the power 2n plus 1. So I have pi over 3 to the power 2n plus 1. Over 2n plus 1 to n plus 1 factorial. Now, if you look at this is sine. At what? At pi over 3. So it will be 3 sine pi over 3, which is 3 times square root 3 over 2, which is 3 square root 3 over 2. And this is my answer. Okay. If you use the mechanical series for sine x, then the sum of the series is this. What will be sine x? Okay, let me open it up. Now, at x equals 0, I have x. At x equal 1, I have minus x cubed over 3 factorial. Then I have x to the power 5 over 5 factorial, and so on. Now let me look at this number. 1 over 6. This number equal to what? This 1 over 6 is not related to anything. Yeah, I cannot get it. Well, very clear. I need to put x equal pi over 6. Yeah, because this is cube, this is 8 over 5. So that's what I should have in my mind. Okay. So this 1 over 6 has no relation to that. Minus. Also, I'm starting with plus. So I take minus common factor. See what will happen. That will be pi over 6 minus 1 over 3 factorial. Pi over 6 cubed Okay, if you look at this and compare it to this one, this is what? This is sine pi over 6. At x equal pi over 6, I have pi over 6 minus pi over 6 cube over 3 factorial plus pi over 6 to the power 5 over 5 factorial, and so on. Okay, that's it. So I have 1 over 6. What is sine pi over 6? Half. That will be 1 minus, that will be minus 1 over 3. Minus 2 over 6, which is minus 1. Okay. If it's the Maclaurin series for this, then the Maclaurin series, you may use differentiation. Okay. Now he gave me the hint. Because I know, yeah, this is f of x. 1 over 1 minus 2x, which is, let me, yeah, so what is f prime? F prime will be minus 1 over 1 minus 2x. Let me do it. Minus 1 minus 2x to the power minus 2. Derivative of this, which is minus 2. So it will be 2 over 1 minus 2x all square. So this, so g of x, and this is g of x. And g of x is the derivative of this one. So I will start with this one. I will start with f as a series. That will be summation in equal. Let me start with x. Yeah. And this. This is x to the power n. So it will be, it's not f of x. 1 over 1 minus 6 is x to the power n. So now my f of x, let me do it in steps. 1 minus 2x. So all x, I will make it 2x. So I have 2x to the power n. Okay. Now I need to differentiate this to get g. G will be f prime at x. Derivative of this, 2 to the power n. Okay. Be careful. It's 1 over 1 minus 2x. 1 over 1 minus 2x. Okay. What is minus 1 minus 2x to the power minus 1? Differentiate it. You get what? Minus 1 minus 2x to the power minus 2. Derivative of this, which is minus 2. So I'm getting 2 over 1 minus 2x all square. And this is my g. And the Maclaurin series for g equal this. Okay. So it's only the derivative. I have 1 over 1 minus x is a summation of x to the power n. As we know it. So 1 over 1 minus 2x, that will be hx, or make it 2. That 2 to the power n, x to the power n. Okay. Now differentiate this. I have n x to the power. Yeah, I have n x to the power n plus 1. Where n is 0. Now n is 0, so at n equals 0, I don't need it. So this is will be summation n equal 1 to infinity n 2 to the power n x to the power n plus 1. Okay, because at n equals 0, I have nothing. Yeah. Okay. Yeah. But I have all the answers n equals 0. But this is not one of them. Okay. So I need to rewrite this one. Let me give it more space. Yeah. Look, I need to rewrite this one. Starting from 0 and the power x to the power n. Okay, so let k equal n plus 1. That means n is k minus 1. Plug it here. Let k equal n plus 1. Huh? Have it n plus 1. Then n equal k minus 1. Is it? No, sorry. This is n minus 1. I find the derivative. This is n minus 1. This is minus 1. I find the derivative, not the integral. So this is minus 1. So I let k n minus 1. Make it the same power. So n equal k plus 1. So if I plug it here, I have k starting from 0 now. N, I have k plus 1, 2 to the power k plus 1, x to the power k. Make it k or n, who cares? Huh? I can call this kn or any other variables. N equals 0, not the same n, but it's okay. That will be n plus 1, 2 to the power n plus 1, x to the power n. And that will be my answer. So what happened? He took the derivative. This is minus, not plus, huh? So took the derivative, and then he a little bit play with the summation. Now, actually, it's n equal 1. Since at n equal 0, everything will be gone. So I can start it from 1. Then he do this trick to change it. K or n, these are just dummy variables. So that will be the answer. Compute the Maclaurin series of this x squared plus arc sine of x. Arc sine of x. Okay. Then let me check arc sine of x. Yeah, that will be arc sine of x. Arc sine of x, give me what? Give me this complicated things. I don't care about. I care about this. I have x plus x cubed. Actually, I need it up to x squared. So arc sine is x plus x cubed over 2 times 3. So arc sine of x is x cubed over 2 times 3 plus the rest. I care only about x squared. Okay. Now x squared plus arc sine of x. It means I need to add x squared to this, so I have x plus x squared plus something. So I can rewrite it. Yeah. So it will be a0. So a0 will be 0. a1 will be 1. a2 will be 1. What they want? They want a0 squared plus a1 squared plus a2 squared. And that give me 0 plus 1 plus 1, which is 2. So that will be the answer. If this is the sum of the series, okay. Yeah, very clear. This is sine. So I have minus 1 to the power n. I have what? 5 pi over 6 to the power 2n plus 1 over 2n plus 1 factorial. So this is sine 5 pi over 6. Second quadrant. So sine is positive, so it will be half. That will be s. You want 2s minus 1. That will be 1 minus 1, which is 0. So that will be the answer. The sum of the series. Yeah. This is cosine. So this is 2. Let the 2 out. N equals 0 to infinity. Minus 1 to the power n. I have pi over 4 to the power 2n over 2n factorial. And this is 2 cosine pi over 4. Which is 2 times square root 2 over 2, and that is square root of 2. That will be the answer. With the following improper integral. Okay, what is this? This is e to the power x. If you remember well, x to the power n over n factorial. Yeah, because with that you need always to remember this. X to the power n over n factorial. This is e to the power x. There's a minus sign. There's minus 1 to the power n with it. Okay. Yeah. So this is 0 to infinity. Summation n equals 0 to infinity. Okay. Minus x to the power n over n factorial. Dx. That will be what? E's minus x now. That will be 0 to infinity E's minus x dx. Now we just an improper integral. Good. Okay. So now that will be limit t goes to infinity 0 to t e minus x dx. That will be limit t goes to infinity. But this is minus E's minus x from 0 to t. That will be limit t goes to infinity minus E's minus t minus that will be plus e to the power 0, which is 1. E to the power minus infinity is 0, so it have 1. That will be my answer. Express this as a power series, no problem. Okay, so I have e to the power x is this. I want ex square. Instead of x, I will write x square. So that will be x to the power 2n. X to the power 2n over n factorial. What will be my next step? I need to integrate this. That give me what? C constant plus this summation. I add 1 x to the power 2n plus 1 over 2n plus 1 n factorial. We open it up. So at n equals 0, I have what? X. At n equal 1, I have what? X cubed over 3, 1 cubed, which is 3. That's it. X cubed over 3. At n equal 2, I have x to the power 5 over 5 times 2 factorial. At 7, at n equals 3, that will be x7 over 7 times 3 factorial plus the rest. So I have c plus x cubed over 3 plus x to the power 5 over 10, 5 times 2. 3 factorial is 6. 6 times 7 is 42. That will be plus x over 7 over 42 plus the rest. So this will be my answer. Integrate this. So you need cosine x. Cosine x is this one. I think now we're doing the same examples back and forth. Cosine x cubed. That will be summation n equals 0 to infinity of what? Instead of x, I'll write x cubed. So that will be x cubed all to the power 2n over 2n factorial. That will be summation n equals 0 to infinity x to the power 6n. What I need the integral of this from 0 to 1 cosine x cubed dx. So integrate this. So I have summation n equals 0 to infinity x to the power 6n plus 1 over 2n factorial. Don't forget 6x plus 1. Okay. Now, this is from 0 to 1. So that will be the summation n equals 0 to infinity 1 over Is there a minus sign? Yeah, I forget the minus sign. There should be minus 1 to the power n everywhere. That give me minus 1 to the power n, 1 to the power something, that will be 1, 2n factorial, 6n plus 1. That will be the answer. Sine x squared integral. That's it. Sine x. Sine x is what? Summation n equals 0 to infinity. Minus 1 to the power n, x to the power 2n plus 1 over 2n plus 1 factorial. Sine x squared instead of x, I will write x squared. Let me do it. Let me do it in steps. 0 to infinity minus 1 to the power n, x squared, all to the power 2n plus 1 over 2n plus 1 factorial. That will be summation n equals 0 to infinity minus 1 to the power n, x to the power 4n plus 2 over 2n plus 1 factorial. Okay. You want to integrate it from 0 to 1. That will be integral of this minus 1 to the power n, x to the power 4n, add 1 plus 3 over this 4n plus 3. Okay. From where to where? From 0 to 1. At 1, I have what? Minus 1 to the power n over and that will be my answer. The current series, the coefficient of x to the power 6. Okay. So I need to do the calculation and then find the coefficient of x to the power 6. Okay. E to the power x is this one. But I need x squared. That will be summation n equals 0 to infinity. X to the power 2n. Yeah, instead of n to n over n factorial. No, don't rush it, don't rush it. I have x squared all to the power n. Instead of x, I write x squared. Yeah, which is the same thing. X to the power 2n over n factorial. Okay, now I have ex squared minus 1 over x. Let me check it. That will be what? Ax squared minus 1 over x. Yeah, let me open it up. At 0, it will be 1. Hey, this is ax squared. Huh? Let me find ax squared. Expand it. Ax squared. That will be 1. At 2, at 1, at n equal 1, that will be plus x squared over 1 factorial, which is 1. At 2, that will be plus x to the power 4. Yeah. At n equal 2. At n equal 2, it will be x to the power 4 over 2 factorial. At n equal 3, x to the power 6 over 3 factorial. That's x to the power 8 over 4 factorial. I think enough. Okay, now let me do ax squared minus 1 over x. And then I will integrate. Minus 1 cancelled with this minus 1. So I have what? X squared. The rest. Over x. That will give me what? X plus x cubed over 2 factorial. Nothing will give me x to the power 6. Yeah, this will give me x to the power 6. X to the power 5, 3 factorial. Plus x to the power 7 over 4 factorial plus the rest. Okay, now I need to integrate this. Integrate e to the power this, which means I need to integrate this one. So I have x squared over 2. That will not give me the coefficient of x. It will give me x to the power coefficient of x to the power 6. So that will be plus x to the power 4 2 factorial times 4, I don't need it. This is x to the power 6 over 3 factorial times 6 plus x to the power 8 plus the rest. This is what I need. So I have 1, this is 3 times 2 times 1, which is 6 times 6. So I have x to the power 6, 1 over 36 times x to the power 6. So this will be my answer. The coefficient of x to the power 5 in the product of sine x and one of this. Okay, what is sine x? X to the power 2n plus 1 over 2n plus 1 factorial with n running from 0 to infinity. What is this? 1 over 1 minus x is summation x to the power n. We know it. Okay, multiply them. And you want the coefficient of what? Of x to the power 5. Okay, this times this. Let me plug it. Okay, now at n equals 0, I have x. At n equal 1, I have minus x cubed over 3 factorial. At n equal 2, this is what I want, x to the power 5, 2 times 2, 5 factorial. Plus the rest, I don't care about the rest. Now, 1 over 1 minus x, that will be what? 1 plus x square plus x cubed plus x to the power 4 plus x to the power 5, and so on. Okay. What do you want? You want the coefficient of x to the power 5. It will come from where? Be careful. Now, coefficient of x to the power 5 comes from where? This product. Okay. Yeah. You multiply the x and multiply it by what? By this one. Okay. That give me 1. Okay. Now, this one multiplied by what? Multiplied by this one. I have what? Minus 1 over 6. Minus 1 over 3 factorial. That would be minus 1 over 6. Okay. The next one. I have what? This multiplied by what? Multiplied by this, which is plus 1 over 5 factorial. What is 5 factorial? That's 120. Yeah? 5 factorial is 1 times 2. This is 20 times 6, 120. That will be the coefficient. The rest will not give me x to the power 5. Okay. Now I have 120. That will be 120 over 6. That's minus 20 plus 1. That will be 101 over 120. And that will be my answer. Now, coefficient of x to the power 4. Okay. Yeah. Of this expression. So I need first to do this one, which is using the binomial. So 1 over cube root 1 plus x, which is 1 plus x to the power minus 1 over 3. Okay. That will be what? K is minus 1 over 3. That will be 1. I need what? 4, huh? Okay. Multiplied by x. So I need up to 3, then multiply by x. Okay. So I have 1 plus kx, which is minus 1 over 3x, plus k minus 1 over 3 times k minus 1, minus 1 over 3 minus 1, x squared over 2 factorial, plus minus 1 over 3, minus 1 over 3 minus 1. Yeah, let me give it some space. So that will be what? That will be 1. K is minus 1 over 3x plus minus 1 over 3. K minus 1. Huh? So let me put the formula in front of us. Okay, this is the formula. So I have 1 kx. K is minus 1 over 3. K minus 1 x squared over 2 factorial, and so on. Okay. Okay, minus 1 over 3, k minus 1, minus 1 over 3 minus 1 over 2 factorial x squared. I need up to x cubed because then multiply it by x to make it x to the power 4. Plus minus 1 over 3, minus 1 over 3 minus 1, minus 1 over 3 minus 2 over 3 factorial x cubed plus the rest. Now multiply x by that. What I care about, only this one, because it will be x, then something, x cubed. I don't care about it. Then something, x to the power 4. This is what I care about. That will be what? Minus 1 over 3, minus 4 over 3. This is what? Minus 7 over 3. All over 3 factorial, x to the power 4. That's what's most important. Okay, multiply. So I have minus 28 over 27 times 6, 3 factorial. This is coefficient of x to the power 4. Coefficient of x to the power 4 is this. Okay, so at 2, this is 14. At 2, this is 3. So it's minus 14 over 81. And that will be my answer. Okay, need to go. Okay. I have x squared over 3 minus x. How to deal with 3 minus x? This one. I know 1 over 1 minus x is this summation. So 1 over 3 minus x, I can take 3 common factor. I have 1 minus x over 3 now. Okay, so I have 1 over 3 times this. Now do the expansion for this multiplied by 1 over 3. That will be what? 1 over 3 expansion of this summation n equals 0 to infinity x over 3 all to the power n. Okay, that will be summation n equals 0 to infinity x to the power n over 3 to the power n plus 1. Now I need to multiply by x squared. What I did is 1 over 3 minus x. Now x squared over 3 minus x, just multiplied x by x to the power n by x squared. So I add 2, n plus 2 over 3 n plus 1, which is